What might you say, assuming I let you know that there is a frozen world floating through the universe as a living fossil? For billions of years, the James Webb Telescope has now found such a living system fossil. This world has not shaped new stars for billions of years. However, it actually exists. What is this cosmic marvel truly about? A fossil system is a universe that comprises essentially of older stars and has not formed any new stars for billions of years. In space science, fossil worlds are thought to be leftovers from the beginning of the universe, and they provide our researchers with entrancing insight into the formative history of galaxies, as well as into the developments in the early universe. Normally, such entrancing fossil galaxies are found at the center of massive galaxy clusters. There, they might have been left over from merging galaxy clusters. By the way, these unconventional systems raise questions. Why did some galaxies freeze and virtually stop growing so early after their formation? And why are these worlds still dynamic in their own way? These galaxies have barely changed their shape and composition since the beginning of the universe, making them witnesses to an epoch about which we know very little up until this point. The James Webb Telescope's mission should ultimately provide us with significant insights into the earliest history of the universe. Since the launch of the telescope, we have been astounded over and over. The telescope is showing us scientific miracles by the dozen, and the list of astronomical interests is growing increasingly longer. We still don't know why and how galaxies formed, nor do we have much insight into why galaxies have been clustering together more and more as the universe has evolved. Research is currently focusing on exceptionally old and distant galaxies that date back to the beginning of the universe to finally see the true evolution of matter. The fossil galaxy that the James Webb Telescope has now found is another exceptional case in the list of discoveries. This galaxy formed incredibly early and very well, expanding broadly for transformative advances that require billions of years for other galaxies. This universe took just a fraction of that time. This burst of star formation is what space experts and cosmologists call a starburst. In a short period of time, the galaxy created billions of stars, forming an ideal curved spiral shape. Then, star formation in the galaxy basically froze, and from that point forward, this world has scarcely transformed. It is considered a scientific marvel how these beautiful galaxies can continue to exist despite the stagnation in star development. It's probably due to the dispersion of gases and the impact of dark matter and dark energy that a galaxy turns into a fossil. So, right off the bat in the evolution of the universe, this is certainly rare. However, the effects of dark matter and dark energy on the development of visible matter and galaxies are still poorly understood, preventing researchers from being able to explain the real essence and elements inside fossil galaxies. The fossil galaxy NGC 1277, in the Perseus galaxy cluster, is one such example. Isn't it staggering that with instruments like the James Webb Space Telescope, we can actually analyze objects millions and even billions of light years from us? Thanks to its remarkable infrared spectrometers, the James Webb Space Telescope can capture light in frequencies that are hidden from the naked eye. Webb gathers the faintest hints of light and then converts them into images that we can see. Thanks to this technology, researchers can now see through clouds of cosmic dust like never before. Cosmic dust is a common phenomenon, and eventually, all matter and all galaxies in the universe are made up of dust and gases. The dust in space can be so thick that telescopes like Hubble often fail due to impenetrable walls of dust. What was hidden behind them remained in the dark for science. Infrared light can penetrate dust clouds, and thus, Webb can also transform these light trails into images. This is how we now see areas of the universe that remained hidden from Hubble's eyes. Hubble was already a success in space exploration, and the telescope had managed to find the galaxy NGC 1277, which is around 220 million light-years from Earth. Despite its limitations, this galaxy is another living fossil from the early epochs of the universe. The stars in NGC 1277 are exceptionally old. Imagine a galaxy in which there are almost only old stars, a structure of beauty, form, and functionality that has barely undergone any significant development for billions of years. Most of the stars in this galaxy are about 10 to 12 billion years old, and as they are now, these stars are far from reaching the end of their lives. By comparison, our Sun likely has a total lifetime of about 9 billion years. It's strange that this galaxy has produced a vast number of very long-lived stars. Researchers would love to understand what processes led to galaxies forming into such beautiful and star-rich structures in such a short amount of time. Moreover, they would like to know if all galaxies in the young universe developed in this way. The starburst hypothesis is currently the most popular way of explaining the surprisingly old and advanced galaxies that Webb has found. Catastrophic events could be the reason why, 200 or 300 million years after the Big Bang, great numbers of beautiful and highly advanced galaxies were already in existence in the universe. In contrast to fossil galaxies, ordinary galaxies have gone through development since the beginning of the universe. Stars were born, stars died, galaxies moved and merged with others, continually changing their appearance and shape. NGC 1277, on the other hand, has not formed any new stars for billions of years. The universe comprises nearly only old, metal-poor stars, as were common in the early universe until the present. However, specialists felt that these old stars of the first populations didn't have an especially lengthy life expectancy in the cosmos. NGC 1277, on the other hand, contains these early, light and metal-poor stars that are evidently truly steady and reach an almost perfect age. Some already unknown systems could have frozen the cycles inside the universe. Seeing precisely what this system is would be the very pinnacle of significance to us, a force that first detonates whole galaxies into development, then freezes them, allowing them to continue in their once-obtained structure. This could show a previously unknown greatness in the universe. Curiously, NGC 1277 contains an incredibly gigantic black hole at its center, which makes up around 14% of the system's total mass. This mass portion is unusually high, and there are various characteristics around this black hole. Normally, this black hole would need to consume a considerable amount of the universe's matter over the course of billions of years, and the universe would shrink, particularly if it doesn't form new stars. Up to this point, it's not known whether the system's black hole has somehow come to a halt. NGC 1277 is also not found at the center of a massive galaxy cluster, unlike other fossil systems. This galaxy is largely isolated in a part of the universe where there are few systems. Now, let's talk about the Einstein ring found by the James Webb Space Telescope, JWST. Have you heard about an Einstein ring? These cosmic objects were long a mere theoretical presumption. It was essentially the mathematical genius Albert Einstein who predicted the existence of these objects, though nobody had seen one for nearly 100 years. Einstein rings are essentially rare instances of gravitational lensing. However, they don't form an amplifying glass-like bend, but an ideal ring. The James Webb Space Telescope has now found a galaxy that actually has one of these objects, known as SDSS J1226+2149. It's another of those exceptional cases in science, and we have the unprecedented capacities of the new telescope to thank for the discovery. Only James Webb's fine sensors could capture the weak emissions from this physical marvel in the depths of space. The Einstein ring around SDSS J1226+2149 was created by the distortion of light produced by the galaxy. An intervening galaxy cluster has extended and distorted the light through mass in such a way that it's extended into a ring shape. In this case, the extending isn't just an interesting physical effect. It also causes a significant amplification of objects behind it. Therefore, an Einstein ring has a similar effect to a gravitational lens. The two effects allow astronomers to see objects that are extremely far away and virtually undetectable to our eyes. Without these effects, the very first Einstein ring to be seen was in the galaxy cluster AL 370. This cluster even offers one of the most astonishing examples of a complete Einstein ring ever observed. This effect allowed astronomers to examine the distant galaxy in detail and gather data about its structure and the rate of star formation within the galaxy. Beyond this remarkable aspect, the Einstein ring around AL 370 is another perfect illustration of how the general theory of relativity works in practice and continues to enable new galactic discoveries. Thanks to the gravitational lensing effect, cosmologists have been able to observe many other objects in the universe. The galaxy JWST is one such object, one of the oldest and most distant galaxies ever found. It has gone down in the history books of space science. It's located about 13.4 billion light-years away and dates back to a time just 400 million years after the Big Bang. With the help of the lensing effect, the light from this galaxy was intensified, allowing astronomers to gain valuable insights into its structure and composition. Thanks to gravitational lensing, even the Hubble Space Telescope made this discovery at a time when researchers thought the telescope had long reached the limits of its power. Another notable discovery is Max J1149 plus 2223, the most distant individual star ever seen. It was also found by gravitational lensing. The star is located in a galaxy about 9 billion light-years away. Without the gravitational lensing effect caused by a cluster of galaxies between the star and Earth, the light from this star would be too faint to be detected at all. The gravitational lens enhanced the light by multiple times, enabling astronomers to study a single star at such a great distance in detail for the first time. Individual stars from distant epochs are a unique treat for researchers. Now, with the help of the James Webb Space Telescope, we can separate light signals like those from Max J1149 plus 2223 into their components. Furthermore, researchers can quickly get ideal examinations of the elements and gases that made up the stars of the early universe. Subscribe to the feed now. We are constantly publishing exciting videos about space exploration and the latest discoveries in space science.